I'm very pleased to present this project. I mean, it goes beyond the MobGap project, to be honest. I think MobGap was really an idea to bring people to do at the European level, but also to have new projects along that. So I have two main collaborators I'd like to thank, Philippe Sier and Valérie Gros, both at LSE. I have more, and I'm sorry I can cite everybody, but Michel Ramonet, Olivier Laurent, a lot of people there. I'll try to give as best as I can a reward to the postdocs and grad students who have had a hard time during this pandemic to actually promote their work and connect with the community. So I'll try to get photos for you so that you can remember them if you see them. The topic today is really on cities and especially on the key questions we have raised recently. The EU was signed for net zero emissions at the national scale, but then cities also are engaged in that fight, and they also want to go to net zero emissions on the same path as cities, as countries, potentially even doing better. I want to show you what the information system looks like today. How do we get information on emissions at a city level? Okay, before I start, I want to thank Nalini, who is now going to University of Oklahoma very soon, Charbel, who is now moved to University of Reims, Champagne-Ardenne, and Jinghui Lian, who is actually a research engineer at Origins.Earth. She was a former PhD student at LSE, so they contribute a lot to that presentation. Okay, so let me give you a brief update of what we call today a self-reported inventories. Self-reported, as you can see it, cities self-report. They have no law specifically, no established national guidelines where by law you're required to do this and that. These are all guidelines. So most common approaches, there are some, and you will find some, but the protocols differ. The emission factors you use to convert a car per kilometer into a CO2 emission number. The scope of your emissions. Do you include only the direct emissions, or do you include the indirect, your energy production component, or even the life cycle of your products that you purchase? Access to data varies a lot across cities. And what is a city? You can have a political boundary, you can have a geographic boundary, a metropolitan. There are many definitions in community across communities. I also want to say a time lag, and this is significant, 2 to 3 years behind, at least. Some cities are 5 years behind, meaning that if today you're a policymaker, you based your prediction on data that is actually 5 years old. At the end, what do we get? A lot of uncertainties. Often no comparison is possible across cities because they haven't used the same protocol. They haven't used the same definition of their cities. And quite often out of date, as I was saying. I mean, there has been significant progress. Let's be honest. Large groups, international consortiums, have done a great work at getting these cities together, at framing protocols, agreeing on standards. So I'll cite some of them here. There are many more existing. But what we need, to be honest, is timely and comparable numbers, so that we can be on track and compare what we have estimated so far. You can do that, and actually it has been done in several places. I show you here one example called the Vulcan product, where for each sector of activities, you can see a full map of the US, the continental US, gridded at 1 kilometer. Every point producing energy across the country, every industry in the country, you can see their CO2 emissions, the transportation network, et cetera, et cetera. So once you have that, the advantage of that is you can scale it to the national numbers. You can see if all the state level, city level, county level will actually match the overall national scale. So once you have done that nice collection, and it takes a lot of time, this has been made by the group of Kevin Gurney at Northern Arizona, you can now extract the cities and compare them to what the city officials have been using so far. And the differences are large, I mean, really significant. Some of the cities, I won't even point out, but go up to 150%. Some of them are quite good. You are within 20% range, but you can see that there is a wide range of values and a systematic bias over all the cities, an underestimation of up to 20 to 30%. This is a major finding because it means that most cities base their projection scenarios and mitigation reduction policies on incorrect numbers. If you go even further, I mean, I won't show you all the details on the sectors, but the sectoral differences are massive. Here is a list of cities, and you can see how some of them underestimate it, sometimes overestimate, quite surprisingly, when they include things that should not belong to their community. So why all that? Well, a lot of the time, some data is just not available, period. For example, the petroleum, fuel use, furnaces at home. Point source emissions, like the industries, they don't want to release their numbers. This is private data. It has a commercial value. They don't want the competition to know exactly what they've done last year. So you don't have access to it. You can also have different accounting perspectives. So what is a perspective on that? For example, you have the harbor of the city. Do you include it in the city? Because politically, it's a different unit. Or airborne emissions. Do you account for flights from Denver to Beijing or you don't? Do you think they're your problem or not? And then different methods for on-road. You have different emission factors, you have different on-road traffic estimators, or you have different traffic data. Here are the protocols and the approaches. I just wanted to show you why we are where we are today. There's a long history of that. I mean, people have tried for a long time to frame very strict protocols where they tell people and explain to people how to do it correctly. But it has evolved over the years. It has changed, sometimes disagree, sometimes agree, depending on the emission factors. And groups have emerged, groups of cities or groups of local governments, bodies. You may have heard of the C40, quite a famous one, or the Covenant of Mayors in the European Union. They all have their own history, I mean, connected with the protocols that they use. So many cities, and if you go even across Europe, will not belong to the same consortium and might use a different protocol. Okay, so if we go back to the inventory themselves, clearly we need to agree more on stricter protocols. We need to agree on how we collect this data and how we convert them into emissions. That's a critical step in the system. But we also need to support the cities at the national and regional level. Because if you want to produce consistent level at your city scale, you also need to have the regional numbers right, connected to the national numbers. Otherwise, you're going to double count or simply forget some of the components because no one has attributed the emissions to themselves. So our ultimate goal is to have an accurate, standardized, and timely information system. Okay, that's the dream. One solution for that, or to get closer to that, is maybe to get more dynamic inventory, like I showed you initially over the entire US, and supported by atmospheric information. And that's what I want to talk about today. The idea is very simple. You can totally see it as an air quality network where you have your emissions and you simply compare them to the atmospheric observations daily. So you start with a very high resolution emission product, for example, here over Indianapolis. You can couple that to an atmospheric model. Here I show some idealized meteorological fields where you see the nice CO2 flowing around the city. You collect data, so you have to equip towers or rooftops or any infrastructure that you have around your city with these very fancy instruments measuring CO2 concentrations at really high accuracy. And you combine the two. And then there is an optimization step where you finally try to see if your observed atmospheric CO2 is consistent with your assumed CO2 emission inventory. Okay, so the very first one I've been working on was Indianapolis. I won't tell you why, there is no good reason for that. But it turned out that we had that Midwest city that we were able to equip with a large number of towers. So this is how it looks, a beltway around the city, a very flat land. We're in the middle of the Midwest, so you're surrounded by corn and soybean. You have the extended suburbs of Indianapolis. It's really a flat city. There is no really dense downtown like you could find in Asia or in some cities of Europe. You will mostly have very, very large suburbs. The towers were distributed all in and around the city. The idea is to have sites that are outside the city because you want to remove signals coming from outside. So you need a somehow background where you simply remove what comes from Chicago and other places around. Just to give you an idea of Indianapolis, it's not a huge city, but it's not small. It's the 17th among US cities. So we're already here at the top few percent of the American city in size. Okay, to make it simple in that test, we simply divided the CO2 emissions into two sectors: the combustion engine, what you would call traffic, but it also includes, for example, construction sites where you have diesel engine running. I won't go into details, but we used also carbon monoxide as a tracer. When you have a lot of carbon monoxide with CO2, you can assume that it's most likely a diesel engine running or traffic. And then the other sectors, you can see how the traffic sector more or less shows the beltway and all the highway connectors and the freeways around the city. Whereas the other sectors are driven mostly by commercial, residential, but also by utility and airport and rail. Okay, so this is what you can get by running this optimization across between towers, and the inventory. This is the traffic sector. You see it's very flat over 3 years because people drive, whatever happens. It can snow, you can have a heat wave, you can have whatever, people drive. So it's more or less no seasonality and a nice agreement between the atmospheric component of the system and the initial original inventory estimate. On the other hand, you have the commercial residential part and the utility also, the energy production. You see a double seasonality. You have the winter time where people turn on heat, and you also have the summertime when they turn the air conditioning. So you have this interesting double seasonality that, okay, we seem to match really well. I'm going to show you that, yeah, spatially we have disagreements. Some part of the city I'd like to increase or decrease on the traffic or on the residential. But on the sectoral level, over the entire area, we're in a nice agreement so far. If you actually start with a small time period, 5 days, yeah, you have a big error bar, whatever you take as an inventory. But as you start to accumulate data, you can see that you also decrease the uncertainty. Well, because simply our data in the atmosphere are calibrated with high standards. So as you get this trend on the long term, you get more and more precise, more and more accurate over time. Okay, so now we went back to the city inventory of Indianapolis, the official one that they published and they use where they base all their mitigation policies. These are these stars, the green stars, a systematic underestimation of about 35%, up to 40 actually, was noticed. The trend is more or less there. Yes, there was a decrease just because the coal power plant of Indianapolis shut down and was replaced by power plants outside the city. But you see this giant mismatch actually that we had between the official inventory and between the advanced, I would say, information system on greenhouse gases. This raises multiple questions. I mean, how do you base your policies based on a number that is overly optimistic, that you're already there, but no, in reality, you're over here. We have excluded simply the scope 2, which means energy production, because it's boldly wrong. When you start with the scope 1 here and you add the scope 2, you get a value that makes no sense. So we also have that problem of information about energy that you buy from somewhere else. You would need to know what this energy produced, how much you bought at what time. So this information is actually currently very difficult to gather for a city. Okay, so this is nice over 3 years, but now we need to look at changes. And Indianapolis was not changing. As you have seen over the 3 years, we have a very, very flat annual rate. It's more or less no movement except that decrease in the power plant, which is kind of artificial to us because it's just the energy comes from outside the city. So let's try about an example that is unfortunate, but at the same time a great example for testing change in emissions. The lockdown periods over Paris. Okay, so this is a map of the emissions over Paris. Same idea, you have towers around. The LSC has deployed 7 towers. I showed you 6 here. There is a 7th one that we haven't used for this study. This network led by Michel Ramonet at LSC has been in place for years, and you can see the 3 years with the inventory. This inventory is made by Origins.Earth, a company, branch of Suez, that actually is now providing these inventories, emissions, as an information system. You can see how the emissions decrease, but you can see also which sectors have decreased. For sure, as you could expect, you could have guessed that the traffic is the main one, but also some other sources. You see the building emissions shut down a bit, some industries, some businesses that actually also stopped. There is a second period of confinement, very different. The schools were open during that second period, some of the schools. So we expect a change. And yes, the inventory tells us that there is a change. First point, we don't know what would have been the emissions of 2020. So the only thing we can do is look at the past and just look at reference years, 2019 or 2018. Well, I'll show you that it actually does make a big difference depending on which year you pick, because each year is different. It's a cold winter or a warm winter. It's a long drought in the summer or not a long drought. So this will change the energy use in the city. Overall, we have an estimate of about 50% made by the city of Paris of the overall decrease in emission due to the first confinement, during the first confinement. Okay, so now if you look at the atmospheric data, it's kind of interesting. You put the 3 years on top of each other, and it's very difficult to see anything. I mean, to spot a decrease over these periods is nearly impossible with your own eyes. Well, because the first driver of this variability is the atmosphere, not the emissions. So we need to remove the emissions in some ways. You can look at the tower-tower difference, which will give you a more local difference. You look at where the wind comes from. You have the wind at the background, and you have the wind downwind of the city. Now, okay, we maybe see that 2020 looks a little lower than the other years, but again, not that significant. If you look at the lockdown period, it's really interesting. the wind shifted. For some of you who remember, that was a really unusual warm spring that we experienced in 2020 in that part of the world. The wind completely shifted here from the typical southwest wind that you will find in most mid-latitude cities to a northeast trend. So you need to remove that effect, because otherwise you're not looking at the same part of the city, you're not looking at the same emissions at all. Okay, so you need to run that model. So we divided Paris into different areas. You have Paris downtown, you have the Paris metropolitan area. Again, this is not a political boundary, because political boundaries are extremely difficult in a physical world. There is no beginning or end at the political boundaries. So we have redefined where CO2 emissions are. So we have cut our own kind of zone that we think is the most intense urban area of Ile-de-France. We coupled it to an atmospheric model and we come up with these estimates. Well, you can see that the reduction that we estimated is quite interesting with the towers, 40 to 50%, quite in line with the estimation made by the city of Paris. At the opposite, the second lockdown was actually much smaller, only 24%. So a nice success, because for the first time, we were able to see a significant decrease at the local scale based on atmospheric data. This is quite a success for us, and it's actually the goal that we really need to achieve, because we need to see changes and not long-term trend of zeros. Okay, so this is what it looks like, because okay, fine, we have a number, but what does it mean? The city was very different during the lockdown. You can see the distribution across sectors. Typically, about a third of the emissions would come from traffic. During that period, we're only down to a quarter. A majority of the emissions come now from the residential and slightly from the commercial, because people stay home. So they simply use more heat. They're not going to stay home and get frozen. You can also see the patterns over a week. That's quite interesting. You can see how people actually on a weekend, for example, or in a weekday, the change is not going to be the same. So you also need to track these changes. So these are information we can collect from a dynamic inventory combined with atmospheric data. And you can see the before and the after. Interestingly, for example, people still need to go and buy food and buy groceries. So sometimes the weekend turned out to be higher than expected. Now, if you look across different products, because there are multiple inventories that you can use, you can know more details about the spatial distribution of these sources that we have discussed before. And you see how these inventories disagree. You can look at it in terms of carbon monoxide, where clearly the Paris area disagreed, or the CO2, where some inventories would actually have higher emissions within Paris compared to outside Paris. This would have a huge impact on our system, because we need to assume a distribution of CO2 emission. Our towers can't see all the fine details around Paris. So we need to rely on this distribution. You can see the NOx emissions, for example, a very good tracer for traffic, shows a clear disagreement on the highway level, highway systems around Paris. Okay, now I've talked a lot about mid-latitudes, but there are other parts of the world. And these areas actually are growing and much, much faster than you will ever see in a European or a North American city. I want to show you an example of Jakarta. Jakarta is special for many reasons. One of them being that the city has a problem with water. The city is sinking, technically. So there might be actually a move of people from the downtown area to the suburbs in the years to come. But anyway, I want to show you what happens when you change latitudes. So here's Indonesia and Jakarta, the Bay of Jakarta here. I show you the topography. It's a very steep terrain. You are at sea level in downtown Jakarta. You go up to 3,000 meters if you're in the suburbs of Jakarta. 3 sites have been deployed by the Japanese agency, NIS. I'm showing you here some work from Masahide Nishihashi in Japan with actually collaborators from Jakarta. Well, what happens when you're in the tropic? It's really interesting. You have mostly 2 seasons. It rains or it rains a little less. And you can see how the regime completely changed our measurements. During a rainy season, our sites completely changed. The wind dynamics, you can see here, driven by actually large-scale circulation, shows you that the gradient is absolutely different. We also, during this rainy season, cannot get any satellite information. So we purely rely on this site data, and I will show you more what we can do with satellites right after. But this shows you the dynamics now, completely different. We need to get into that dynamics and see if these changes are purely from a meteorological standpoint, or they're also from the behavior of people. We can expect that during floods, the traffic will change, and the behavior of people within the city will change. I'm also not showing that, but the contribution for the vegetation was as large as the fossil fuel emissions themselves. So extremely productive vegetation that we have around Jakarta. Okay, so what about the rest of the world? It's nice, but To be fair, a CO2 network today is maybe several million dollars in current status. It will take you years to actually analyze the data, have a system ready to go. So this is not really something you can expand to the rest of the world. It will take us years or decades before we can get enough measurements around. So one option that we have is satellite. It's quite convenient. It can see the entire world as long as it's not too cloudy. But it has also its own challenges. So I want to show you where we are on that aspect of the work. First of all, and I always said that, but it remains expensive, really expensive. Just to give you an idea, $50,000 per instrument. We are trying to develop low-cost and mid-cost sensors, but it's still ongoing. We need to make sure that these sensors are reliable, they're accurate on the long term. The urbanization, fossil emission growth are taking place in emerging economies, meaning you have no inventory. Most of these cities have very limited access to information. It's not their priority to actually have a CO2 emission inventory, as you can imagine. They're growing very fast. And here I just show you a plot of the emission growth and the pollution, the AOD trend from the satellite. And you can see it's interesting how some countries have been able to tackle their air quality issues, like China, that has put in place very strict measures since 2015, but not their CO2 emissions. You can see how they are grouped by continents. So it's quite interesting to see the trend in development. You have emerging economies, really industrialized with fast growth, that cannot really stop. Their economy relies on that, where other countries, more on the service providers, are actually trying to tackle and get negative trends. The real problem, though, is in these areas where you have a lot of population and emerging economies growing very fast. Okay, so very briefly, this is what satellites do to measure CO2. For now, we have passive instruments. Some active missions are developing, but it's a passive instrument. So we simply measure the reflection of sun rays and see how much has been absorbed by CO2 in that case. Two main missions right now flying. There are more to come, especially the microcarbon and Sentinel-7 mission coming by the European Space Agency. But for now, we have two NASA missions flying, the OCO2, that actually measures with these tracks really fast around the world. Unfortunately, you see a track every 2 weeks and a lot of space in between two tracks. So meaning finding the right track at the right time near the city might be a challenge, and it is a real challenge. Now there is the CO3 mission that has been installed on the International Space Station, which has a scanning mode called target mode, where you can literally scan and do multiple bands over the city. It's not really a map. Let's be honest, these will be bands that will cross your city in one direction or the other. It's a limited number of images, but for the first time, we get some sort of pseudo maps over cities that we can use. So here is the typical, and I'm sorry, I couldn't find this photo of my graduate student, Alexandre. So for now, he will be this mysterious man on my slide. So this is a typical CO2 track that here near Lahore in Pakistan, a very large city, major industrial center. When you're very lucky, the track is right next to your city. The wind blows in the right direction, meaning you're going to cross the plume coming from the city. So you get this very noisy data set that you can actually try to average and smooth. And now suddenly you see a plume magic appearing on your track. And this doesn't happen very frequently. I would say that if you're lucky, you might get 3 or 4 plumes a year or for a given city. Lahore turned out to be located near an CO2 track, so we collected as many as we could. Yes, first order agreement, we confirmed it, but the trend detection is statistically impossible. We don't have enough data right now to see if the city's emissions are growing, or increasing, or are decreasing. Huge data loss. What we realize is because of clouds and aerosols and albedo problems, we lose up to 80% of the data we collect. So even when you're lucky and you have the track on the right day with the right wind, you're still very likely to lose it for other reasons. Let me show you a CO3, which is actually more promising. At least it gives us a better view of what we could collect in the future when we'll have these imagers covering the world. Here is Washington, D.C., Baltimore. You see the Chesapeake Bay here. For those of you who are familiar with that part of the world, it's the eastern coast of the east coast of the US. And you see here the 3 tracks that OCO3 has been able to collect. You have a piece of a fourth one that you see. So they recover the data depending on albedo, as I was describing before. And you can run the model, exactly the same thing as we have done for the towers. I could show you track by track what it looks like. You see plumes. You see also disagreement at the subscale. You see that some small features that you can see from the satellite are not really visible in the model on the upper panel. But overall, the enhancement from the city is right here. Okay, you can also see it there. It's very noisy. What we found is it's extremely difficult on an image per image basis to actually see clear plumes and try to match with a model. It's a 120-second snapshot. So it's really fast. Your model has to be right at the exact time when the satellite is over. It's a first order agreement. Yes, we do see the enhancement from the plume here. You can see the model capture it as well. It's a limited data set, but it's still 10 full images, much better than what we had before. Now, if you start to average the images over a month, that started to be interesting. I took here the Sentinel Tropomi missions. It's an NO2 mission for the most part, also measuring methane. And you can actually average over time. And now what you see is not at all a plume structure, but a some sort of monthly anomaly that you will see over the city. So now, okay, now you see where the model starts to agree with you. You have the anomalies here located right over the city. And you see that over time, as you actually start to average out, average more and more images, you start to see the actual real correlation that is pretty high. So now that being said, it doesn't mean we can use these averages. They're quite complex. We would rather use instant images and try to make sense of time series. But for now, we know that the information is there, that the model tools are ready. Are we sure now that we can extract emission trends and emission quantities out of these images? The question is still open, and a lot of work is ongoing right now as I'm talking. Okay, I wanted to make some sort of overarching conclusion because it goes beyond that. Metropolitan areas lack proper tools, and I think that some cities might disagree because they have made tremendous efforts to get a team, and some of them have done it. You will find cities with 5 experts working full-time on building an inventory every 2 years that is quite good, but most cities have not. Dynamic inventories, yeah, it's a first step toward monitoring. It's really useful. You understand better where your emissions come from, what drives the changes, which sector is actually more important than others. But it's not all, because you also need to keep track of that on the long term. You need to standardize them. This is going to be a really hard step. Many cities, many institutions, many organizations. So standardization could also benefit. Atmospheric system could really benefit standardization, because now you do have atmospheric data that we do calibrate at the global scale. We have WMO standards that we use. So all these sites are calibrated. So we could use also that to compare cities. And we have long-term accuracy. Okay, now if you look at the objectives of the cities in the coming years, it's quite ambitious. It's going to be a really steep decline. We need to get there. The problem is how long before we realize we are on that trajectory or not. If it takes you 10 years before you realize that you haven't achieved what you were supposed to, you're really in trouble. You have really created a giant gap and a delay that you need to compensate. So the idea is to be able to keep track of these changes every year as fast as we can to make sure that if what we thought would work didn't, then we can change rapidly, put new mitigation policies in place, and try to get back on track to achieve our goals by 2030, 2035, and 2050. Now, really a key challenge, it's not to limit ourselves to the EU or to North America. Yeah, it's easier because you will have more funding to make a nice and fancy network around the city, but it's not where the emissions are really increasing. The developing world is really the key area for now, and we really need also to tackle their development problems. How can we make sure that they develop while not exploding our emission trends? Because whatever we can do at the Paris level would be completely overwhelmed if a city in Africa grows to 30 million people. So thank you for your attention, and here for institutions that I've worked with or at. Thanks again.
Okay, thank you very much, Thomas. Very interesting talk, really fascinating from my viewpoint as well. Yeah, as I mentioned in the chat, please ask questions via the question and answer tool. The panelists can also just, if you have questions, please just go ahead. Otherwise, I might ask the first one, which is how much emissions actually come from, let's say, the largest 100 cities?
Oh, it's actually a very small fraction. In the US, I would say we calculated the first, I remember, 100 cities were 6% of the total emissions. locally on scope 1 level. Meaning that it goes to another, and it's a good point because it goes to another problem. We don't need only to monitor Paris. We also need to monitor small-sized cities and medium-sized cities, and this will be even more challenging. These cities have even fewer people to help them build an inventory, and the signals are going to be even harder to detect for the atmospheric system. So this is an additional challenge. So some projects started on mid-sized cities like Reims. There are places where we really need to tackle. Most European people live in cities of 300,000 people, more or less. So we really need to go down to regional systems, potentially keeping track of these mid-sized cities on top of these giant cities that we've been focusing on, to be honest, in the last 5 to 10 years.
Okay, thank you very much. Still no questions. I hope you still are thinking about or typing them right now. Otherwise, I might ask another one. You just very shortly like said, okay, in Indianapolis, they shut down their coal plant or whatever they had, and they built one outside of the limits of your detection to some extent. So how much is that of a problem in like the global view of climate change, and how cities maybe even doing that they just export their problems?
Yeah, it was a fantastic example for 2 reasons. The first one is how the city promoted it as a switch from coal to natural gas. So that's the first thing they would use in their communication. The reality is that a coal power plant is not at all the same as a natural gas power plant. A coal power plant runs as a baseline. It produces the most of your energy. You cannot really turn it on and off as you like. The burners are slow. You need to load with coal, and then it goes. So when they switch to natural gas, they switch technically the essence of the power plant itself, but they still need the energy to feed the city. So now they have a choice of this natural gas inside, and they still need to buy energy, but they have no idea about the scope 2. They don't know exactly what they're buying and where from, or at least we don't have access to that in details, meaning you have no idea what has been substituted. That coal to natural gas is a percentage, a fraction of the original power plant. And then the rest might come from another coal power plant somewhere in Indiana that is cheaper than natural gas. So it totally depends on the price of energy. It might change from month to month. It could change also for political reasons or for many different reasons. So it was quite interesting to see at the local level how this thing was oversimplified and simply said, oh, fantastic, we have decreased by 20% our emissions. We're done for the coming 15 years, more or less, in terms of commitment to emission reduction, where in reality, we have no actual number to prove that, and we don't even know where the energy comes from to this date, on top of this 35% underestimation that we discovered.
Mm-hmm. Okay, before I get to the other questions, maybe one to finish this topic. So what do you think, where is Indianapolis and where are cities at all on track, or how can they become carbon neutral, or what is possible? I guess it's
well, it's a complex question. I'm going to take it the very simple level. The cities belong somewhere. They have a country around them, and so there is a national scale initiative. If you look at a city itself and the city governments, if you look at their governance level, how far can they really decide? A stupid example, the city of Paris doesn't have control on its public sector, transport sector. It's a regional system. So it means even if the mayor of Paris has the best intentions in the world, they still need to find an agreement with the region in order to develop the regional system and replace the cars by public transportation. So if you look at the percentage, a fraction of the emissions of a city that are really controlled by the city level, I've seen estimation around 10 or 15% of the total. The rest of it is decided at the largest scale. And I'm talking only about the direct emissions. I'm not even talking about buying a cell phone coming from Thailand. This is completely out of topic right now. And so it makes me feel that the cities need help. We cannot rely on the fact that, okay, the governments are slow to move. And so cities found an opportunity to just say, it's time to take control on that. We can move, we can push our citizens to actually do things. And they've done a great job. But their action, their space, their governance level is really limiting. So I can see cities as great examples, but they need to be part of the larger national scale discussion. We need to put them in a larger framework and just say, okay, now we're going to change the traffic rules in the future so that cities can help and contribute. But cities alone cannot do the job. We can't just ask cities to do whatever we have failed to do at the national level.
Okay, thank you very much. So now I have several questions. I will read them in the order they came up. So first was Louis Derry to ask, what are the prospects of getting much better satellite coverage of CO2? Is this possible in the next decade or so?
Yes, 2023 GeoCarb over the US, geostationary mission measuring CO2 methane. It's an active mission. It's quite challenging. I hope they will succeed. The next one is a European mission, ESA, Sentinel-7, with a constellation of satellites. So then we will have real maps like we do have for Tropomi, for methane and nitrogen oxides. So missions are growing. They're not that many. If you look carefully, the big push right now is on methane. Leak detection from space, from oil and gas. This is where a lot of private investment has been really rushing. For several reasons. I would say, first of all, because it's easier to see a leak in space than to track 5% change in the emissions of Berlin. So there is an incentive behind also is money. You lose natural gas, you lose money. You emit CO2, you don't lose any money. You actually make money most of the time. So we need to be very clear that these satellite missions are maybe challenging, but in many parts of the world, there will be no network. I mean, it has been a headache to maintain 3 sites in Jakarta for a few years. It's maybe the only tower network that I know of in Southeast Asia. Africa has absolutely 0 urban stations to monitor. There was an effort in Cape Town years ago that has stopped because the graduate student left. So the most critical part of the world are completely unmonitored. So we need to push, and even if the satellite has a lot of technical challenges, I don't see how we will go around it.
Okay, thank you very much. Ramachandran raised his hand, so please go ahead.
Thanks, Rainer. I usually go by Subu, but Thomas, thanks for the talk. So maybe I missed this, but when you say that the top 100 cities in the US had a carbon footprint of just 6%,
yes.
You're
on direct emissions, right?
Well, of direct emissions, right?
Yes.
I mean, so this gets to the other point, is that hundreds of millions of people live in cities, and we all use electricity of various kinds. And so when maybe this is a philosophical question, is that what's, if you only count the city's footprint as what is directly emitted from the city, then you're discounting a huge fraction of electricity. And I mean, so now obviously everybody's using, fossil fuel vehicles, right? I mean, cars and trucks and cooking and all that, this is all really all fossil fuel driven.
Right.
But once you start moving to electrification, I mean, these have other benefits: reducing fossil fuel use. If you use induction stoves at home, then you reduce indoor air pollution, for example. But all of this just moves the CO2 emissions away to where they are currently. I mean, in Pittsburgh, most of the electricity probably comes from the steel. Yes. All the electricity power plants outside of Pittsburgh or wherever else. And so, how do you account for that? Is that a fair assessment to say, well, cities only account for 6% of CO2 pollution?
Right. So no, you're right. It's a very good point. So technically, we make always the joke is like scope 3 is the scope 1 of somebody. And if you look at the US, if you actually could cover the entire country, you would have, I think 60% of the scope 3 of a city is within the US. So that goes back to exactly the regional and the national scale. We need to make sure that we have the power plant in Indiana that is feeding some energy to Pittsburgh, so that now we can link the scope 2 of Pittsburgh with the scope 1 of Indiana. And at this stage, we're not able to do it. So if anything happens on the scope 2 market, we don't really know how it's going to impact the city somewhere, but we can see it locally. And that's really critical. The scope 3 is outside the country, becomes very difficult. And also we have no political control on the scope 3. So far, it's very difficult to implement a full control of scope 3. We don't even know where products come from. I mean, there are tons of papers trying to track these products where phones have been built. So I'm not going to go there. But on the scope 2 level, yes, we need totally to link the scope 2 with the scope 1 and cover the entire energy grid to make sure that when we track the emission from, I mean, Heidelberg at this example, they also had a power plant that moved away from the Heidelberg area, and they just said, oh, wonderful, we decreased by 30%. This happens again and again and again. And cities hide behind that thing. It's very easy. It disappeared from my territory, therefore it's not mine anymore. So you're right. We need to get that into a larger picture so that no one can really escape the energy use and the reality of energy production. Sorry, right.
Okay, thank you very much. I will combine two questions. One was, I mean, could you first of all explain a little bit what scope 1, scope 2, and scope 3 means? And then we have here whether we are missing a large part of CO2 emissions by not taking into account the scope 3 from Lauren Olemon. And then we have another question by Hazel Ulet-Bonan, whether the emissions linked to consumer goods are included in one of these scopes, maybe.
Yes, it's a great way to combine all that. Okay, so to make it very simple, scope 1, direct emissions, you turn on your car, CO2 comes out of the car, that's scope 1, it's local. Scope 2 is you turn on the oven, which is electrical, and there is a power plant somewhere outside that has been producing energy, and so you use that. So what I showed today is almost entirely scope 1, because we only see what has been emitted in the area. Scope 3 now is the last one. It's when you buy a cell phone made of components built in Thailand, China, etc. All these components also required energy that you could take into account and add. Ideally, you want scope 3, you want the full picture, because scope 3 represents the largest fraction for cities from far. The cities consume a lot of goods. They produce very little. Most of the time, the industrial areas are not around the city. You don't want a giant steel factory in the middle of Paris, no way. So typically what you're gonna find is actually a huge input, but it's very hard to track. We really struggle to see where the goods are coming from. And even if you knew where they come from, what do you know about the emissions in Thailand? You need to know how much it costs to create a component of a cell phone in Thailand. So they're very hard to track. We started with scope 1, saying if you cannot even measure your scope 1, you're in real trouble. Don't even start scope 2 or scope 3. Once we will know scope 1, the direct emissions, then you can start to say, okay, now I'm going to look where I buy my energy, and then you can see how much it actually represents. And finally, when we have all that, we can really say, okay, now it's time to see for what we have actually imported, how much comes from these other countries. There's a lot of reasons not to do it. I think political and economical interest are behind that. So yeah, at the end, scope 3 is the big one, is the huge one. It's always has been for a city, for local governments, to be clear.
Yeah, okay, thank you very much. So I guess with satellite missions, one should get to scope 1 everywhere, and then one would have, to some extent, all global emissions. And probably
exactly.
Countries where the goods are produced will then maybe even like to trade their emissions, right?
Exactly. Your scope 3 is the scope 1 of someone else. And it really pushes towards a global monitoring system where you can really keep track of what has been traded, how much, and where it happened. And cities cannot claim just because the production is not within their political boundaries that it's not theirs. The avoidance has been. So how do you trade? Who is paying for that? I'm not going to get into that discussion. It's endless, and they're very smart people who were thinking really hard about that. Who pays for it? And that goes more into the trading problem.
Yeah.
I feel at the city level, when I talk to cities, it's not their first interest because they have very little control on it. At this stage, the city cannot stop you from buying a smartphone. Maybe one day it will become a reality, but so far, you can buy whatever you want. It would be the most CO2 rich smartphone in the world. You have the right to buy it.
Yeah. Okay, another question from James Clark. As monitoring improves, do you anticipate that municipalities will exploit your results for planning decisions? Will they pay attention to this? Or if you want to add, James?
I could, yeah. Thanks, Thomas. It was a great talk. I'm not an atmospheric scientist, but most of the grant panels that I sort of interact with, whenever you're dealing with, research projects that involve monitoring or prediction, the broader impacts involve, how do you actually get this out to the people who will use it? I was just struck by the fact that here you're generating products with really direct application to all kinds of very immediate policy decisions. And I just wondered how you actually interact with municipalities. Do you just generate results for the academic community, or do you sort of take what you find and have some more direct connections to the people that would use this for planning decisions?
Yeah, it's an excellent question. Okay, it's recorded. I have to be very publicly wise. So I would say, here we go. Now, to be very honest, cities have been used over the last 20 years, 30 years to pay for an inventory. And if you look at the IPCC level, the inventories is really kind of the holy grail of how you account for your fossil fuel emissions. At the local level, it's about the same. The standards, the trust is in the inventory. We come in the game and we tell them that what they have done for the last 20 years is actually not as good as they thought. First of all, they're very honest people. I don't think there's a lot of inventory experts who would say, I just remove that component so my city looks better. Sometimes they tend to not bother. So a lot of municipalities have been really happy with what they had. And then you come into the game and you tell them, well, your inventory is 30% low. Sorry, but your objective now is huge compared to what you thought. You will never get to that level because you'd never counted for that. Or why did you dismiss your airport? Or because it's not in my municipality. So we got a lot of push back and forth. They like it. They think, oh, it would be useful, but they also worry about what they're going to find. The inventory people, on the other hand, they know that they're missing information. They know that some industries are not reported the full emissions. They know that they have missing a lot of details. Sometimes some cities don't even know the domestic fuel use. They don't even know who is connected to the natural gas network, who is connected, who has a fuel tank at home. This information is really hard to collect. Houses are old, some are new build, old build. Sometimes there is a tank, but they use the natural gas line. So it's extremely difficult to connect these dots and make an inventory that makes sense. So when we talk to cities, it's complicated. They're experts, trust their inventories, they believe in it, they spend a lot of time on it. It's hard to hear that, yeah, we've been missing 20% of our emissions for the last 5 years. Now we also need trust. We are not a standard. The atmosphere has not been seen as a standard, to be honest. We look at it at Mauna Loa as a standard, which is kind of, it's the reference, right, in the world. We know the world has increased by X amount and there's nothing you can say about it. But at the local level is another story. You can always accuse me of having the wrong transport model, having a biased optimization system, some inaccurate atmospheric data. So we can get attacked. We don't have standards. And that's why I work with WMO. We need these standards. We need to prove to the world that these systems are not stupid, that they don't tell you a story that is just good for a technical journal, just to make the next headline of Nature Communication. We need to show that, no, this is true information, that we can really rely on it, and that we should improve the inventories that at the end, we converge. It's been hard, push and back, to be honest, at the end. The city of Paris, very supportive, extremely supportive. We have the experts all the time. We discuss with them a lot, but no funding and very little action so far based on our discoveries. In the US, it has been very strange. For example, we had cities that completely ignored us. In the city of Indianapolis, I think it was really interesting. We would discover news articles about our network. They would promote it as a very cool R&D, new technology thing, but they will never ask us for any information. So a complete denial of what we have found, and at the same time promotion saying, oh, we're a CO2 city. California has been really pushing for that. So the Air California board has been putting new regulations, and it's maybe the only state, or it's not a nation, but it's a state, that I would consider really having now legislation on their reporting. It's mostly inventory. There is some wording about using atmospheric data, but it's not a clear requirement, and it's not that obvious. But they are moving towards that. We see it in the methane world more and more. It's a much easier topic. But the city level, I agree with you. So far, we're not really getting heard. The trust is not there. We need to push the boundaries of what we have done so far. And to realize that what you have done for 15 years is not good enough is hard to hear. And I can totally understand that. Yeah.
Okay, thank you so much. Very quick question. I would like to get a very quick answer from you, actually. That is the CO2 satellite systems, they are also tracking over Africa and many regions. Is the data publicly available, and do the cities take that?
Yes. It's a very physical thing. An American person in terms of emissions per capita is actually much lower than an American, as you can imagine, and as many other countries. So interestingly, we have a detection problem. These cities are very large, but emissions are hard to see. So there are a couple cities that we have started to look at carefully. most of them, Nigeria, for example, has very large cities. South Africa has a couple of large cities that we can see, but the detection level is right on the edge. So we can see right now, and we work mostly on giant mega cities of 10 million plus, with a certain amount of per capita. On top of that, you need to make sure there is no aerosols. Aerosols really limit your capacity to detect precisely, to quantify CO2. But yes, we should be really thinking about it. It's going to be a clear trend in the coming 20 years. They really need help, and they need monitoring. So yeah, I hope we can do it soon.
So if things work well, you will be out of your job, right?
I hope for that, to be
Okay.
honest. I'd like to work on something else.
To a question again by Hazel. Sorry if I pronounce the name wrong. That is whether including low emission areas in cities help. So.
Oh, sorry, I missed that. Could you please?
It's in the question and answers, not in the chat. Are low emission areas within cities a solution at all? For example, in Barcelona, he writes, or she writes, that they have these recreational areas, but you also have the huge cruise vessels coming in. And so what is the...
It's a weird thing. It's like moving. There is a little of this boundary game. Is it my political boundary or not? Can I move it out? Like city, for example, Paris says, oh, we don't want now cars to move. We're going to limit traffic. Well, you're going to have a backlash. You're going to have the suburbs starting to explode in terms of traffic. So these things are going to flip. Yeah, I agree. These low emission areas just move the problem in a lot of ways. They don't really tackle the real issues of CO2 per energy produced.
Okay, then I have a question by Peter Odiambo, whether inventories of all carbon sink activities can be done in cities, municipalities, and...
Yes, totally. So at this stage, very little is done on the green carbon. Cities have a really low level of information. I mean, their parks, their forested areas. That being said, to be honest, in terms of a carbon pool, it's a ridiculous amount. I mean, we made that very simple calculation. Parisian people have a tendency to overheat, the comfort temperature around 17 degrees C, something like that. If you want just 1 degree of overheating in Paris would require that you plant half of the surface of Paris in trees to compensate. So it's a ridiculous amount. So I think the green is really important in terms of air quality, in terms of quality of life, in terms of many aspects. But in terms of a carbon pool, I would totally drop that idea. So you would have your pool somewhere else. And it's what most cities are starting to look at. They buy a forest somewhere far away to compensate for the emissions. But I've seen very few cities really counting on their green fraction to actually do anything about their emissions.
Okay, and that means also changing our behavior is the most important thing in cities.
Totally. Yes, within their action. Yeah.
Subu actually raised his hand again, has another question. Please, Subu.
Great, thanks, Rainer. Thomas, so when you rely on satellite data, I think in air quality, we have the similar issues in that, you raised a very interesting point that you have to be lucky that the overpass is near your city, the wind is going in the right direction. And so the satellites only measure at one point in time. It's a snapshot of the day, for example, right? Yeah. And they can only measure, I think, during the daytime. Yes. The same thing for air pollution. And so do you think that creates a bias? I mean, your citywide network, makes a really nice comparison for that approach.
Yeah. No, totally. You're totally right. It's even worse than that. If we have numbers for cities on the annual timescale, usually we try to make them hourly, but we make it up, right? We have some activity data, proxies, and then we try to make it up. And then we try to match at 2 p.m. on October 15th as an annual inventory with a snapshot of the plumes. Yeah, I totally agree. There are plans against that. I would say to fix that, a couple of them, the geostationary mission. So NASA has invested massive amount of money for a geostationary satellite. So now they can measure multiple times a day. It helps you get some of your diurnal cycle. Active missions. I mean, we're looking at a 20-year R&D time window. Active missions in methane has been proposed that could also measure at night. We could imagine that one day it will be possible. Right now, we lose so much. I mean, the track is one thing, the clouds are another one, the aerosols. I mean, I told you 80% of the data is lost before even you start looking at any data. So yeah, the investment for satellite is massive. And I was hoping that the private investment would actually fix that problem, because it's not going to be a public trust that is going to inject billions of dollars. But the push is on methane. I hope tomorrow it will be CO2, and we'll have a real incentive to do it. The key to that is putting price on CO2. Once it will have a value, maybe we'll see emissions appearing. But so far, yes, active emissions and geostationary, with its own set of challenges. It's not simple, what I'm saying. So maybe it will be too late. By the time it's 2050, you will have your first active LiDAR mission. It's a good debate. I don't want to go there, but yeah.
Thank you.
Thank you very much for this answer. I have one final question here, also in the chat from one of the attendees, and that's what are the challenges in Africa to implement the Paris Agreement? And I think Subbu might even also be able to answer a little bit on this. So maybe Subbu first, and then Thomas to have the final word.
Sorry, apologies. Could you repeat the question?
What's the challenges that Africa faces to implement the Paris Agreement? I think you might be a very good person to answer to that.
Oh, I actually, honestly, I wouldn't. I think Thomas is a better person to talk about greenhouse gas emissions. Go ahead, Thomas.
Okay. Sure. I think the target, yeah, it's extremely difficult to me. I'm not sure if I would go in the science. It's really a policy question. To implement really these changes when you have a really fast growth and you need that growth because your economy needs that to develop, it's extremely difficult today to have the capacity to invest in clean energy. It's costly. So it means in some ways you need some external financing to actually have the capacity to invest in clean energy. So to me, this is really where the tracking, the monitoring comes in place. The growth is needed. I mean, in many ways. I mean, in terms of quality of life, improvement of quality of life. If you don't want the carbon, because the CO2 per GDP, I think is impossible to kill. So if you develop, you increase your emissions. So to me, this is where, if you were able to monitor, then people would be able to invest. Because you could see that the cuts you have implemented at the African, in the urban African city, for example, now you can monitor it and you can say, "Wow, amazing! The GDP grew by 12%, the emissions only grew by 1%." So this is also the power of the monitoring systems. It gives information, trust, confidence for people to actually change their way of thinking. Where today you invest in a forest in Africa, you don't know what's going to happen to that forest. We develop systems, satellite data, to track forest changes. And right now, people are working really hard on high resolution biomass and et cetera, monitoring. But if fire starts next year, your forest is burned. So I think there is also a huge potential of attraction to say, instead of getting cars all around Dakar, you could invest in the next public transport in Dakar, and we're going to track the CO2 emissions, the development of the city. So it gives also incentive. So to me, the challenge is the lack of trust, lack of information, lack of collaboration. So this has to be worked on. And I'm looking for next month, there will be, in 10 days, there is an African summit, climate change. If you can look at it, really push people, I mean, people should really get log in. It's a really interesting push of all the inventory, carbon emissions and initiatives made in Africa. It's a lot of West African countries, but there are many of them that will join. So things are being done. They're just maybe not as visible as the EU and North America or China, but things are getting done. Yeah, so, much more than we can imagine.
Yeah, I mean, I can add a couple of points which are related, but I think one of the challenges, for example, I work a lot in East Africa, and one of the challenges there is actually that there is an underutilization of existing electricity. So, for example, they've invested a lot of money in power plants and generating electricity, but they don't have enough utilization. So there is, I mean, the challenges are quite different from what people in the West often face. So that's number one. So if you start using more electricity, would you have more CO2 emissions? Well, there is the investment to recover, right? I mean, there's a lot of loans to be paid back and things like that. The second thing is actually, so the one initiative that did happen recently was that I think in Kigali, there is an electrification of the motorcycle taxis. So these are fossil fuel powered before, and they do create a lot of urban air pollution, but converting that to electrified motorcycle taxis kind of avoids that problem, plus I guess solves some of the earlier problem of how to use electricity that's being generated anyway more effectively. I think some of the other issues like ecological issues, I think there was a recent report that the wetlands were contributing a lot of greenhouse gas emissions from Africa. Well, how do you control that? I mean, these are wetlands and they're affected by ecological changes, which will be, the changes can be further, exacerbated by climate change. So it becomes a sort of a chicken and egg problem. And so, and these wetlands might be national, they might be regional. So how do you account for that? I think you come into those governance issues. So I think there are natural challenges. There are, as Thomas said, there are growing population and growing economy that needs to be supported justifiably. What's the best way around it? Again, I think the footprints of a lot of these countries in Africa are, I think, relatively small compared to the West, compared to where rich economies are. And I think the focus perhaps should be on the high GDP per capita countries rather than growing economies.
Okay, thank you very much. Yeah, I think it's 5:10, so we are already quite over time. I think that was a very interesting and lively discussion. Thank you very much, Thomas. Maybe I just remind about the Climate Chance Summit in Africa 2021 in about 2 weeks. I also liked your last words that, okay, there's things being done also in Africa and of course everywhere to change these things. And yeah, I think you very well pointed out that we also need to monitor this and need to make people accountable, so to say. With that, I would like to close, but I would also like to remind you that we will have next week another seminar. This will be Louis Derry, who will talk about what's in our water and why can it change with climate. So Louis will talk about watershed modeling and how like river systems might change with climate change. I think that will be very interesting, especially for German participants of the seminar, as we maybe Louis, you also heard about the devastating floods we had here in Germany. That was very yeah, devastating, and maybe there will be questions to that next week. So with that, thank you very much, Thomas. Thank you very much to everyone for joining. I hope you enjoyed the seminar. I did very much, and see you next week.